Hello everyone, welcome to your new lesson. In this lesson, I'm gonna really take a very interesting topic. It's a resume, or you can say a CV summarization. So it's a resume and the CV summarization. In this, we will be taking a PDF resume or a CV, and then we will be summarizing that CV to get the name of person, its emails, and the organization in which that person has worked and its skill, etc. So it is really very helpful for the HR people who receives a lot of the resumes and CVs, and they are not able to go through all the resumes at once. So with this summarization, they can go through all the resumes very quickly and they can get the required information, and it can be extracted. But the one thing all of you should remember that the collecting the training data is incredibly painful. So it's not as simple as it seems. Okay, yeah, we are gonna do today resume and the CV summarization. Whatever we do in the data analysis or in the deep learning trainings or NLP, etc., we need to first prepare a data. If we are a beginner, we get the data directly from the Kaggle and from other websites, etc. And we start building our model on the already prepared data set. So that seems a very easy task. But whenever you try to implement something which is not available in the market, then you need to first prepare your training data for the machine learning algorithm. And this is the where most of the work need to be done. Collecting and preparing the data is most important part of deep learning. Okay. So the data for this resume and the CV summarization is prepared for around the 200 CV on which we will be training our algorithm. Yes, it's around 200 the CVs on which we will be training our data set. But the 200 CV and the resumes data is not enough for a large organization. You need to get the thousands and the thousands of the CVs and prepare it manually so that you can train it on the larger data set for a better accuracy. So let me show you the data which I have here. Currently I have data in the form of, let's say here, the train data.txt. If you open this, you see here the data. So this data I had taken from the internet somewhere, but I'm not able to find the link from where I had downloaded this data. And then on this data, I written the algorithms in a SpaCy for its processings and for the classification. So I'll upload this data on the GitHub and then you can download it. So let's say you have this data, okay? So this data seems the pretty much it's not making a sense. All right. So let me explain it to you in the parts. Then definitely it will make some sense. So with this whole data, you see this is a tuple, and in this tuple, if you notice that there is a tuple which starts from here, okay, from this entities. All right, and it ends here. And before this, you see, before this, you have this whole data. Okay, so this is the whole data. So in this tuple, this is the first element of this tuple, and this is the second element of this tuple, which is in the form of dictionary and then the list of tuples. So this is, you can say, a key of this dictionary, entities, and then there is a list. And this list is having here, these are the component of this list and these are the tuple. Okay. And these tuples, this is the third index. At the second index, you can say here, this second index says that here the label, okay, the named entity recognition or a label for this particular data set. Okay, and it is similarly for all other data set. So how it is done? let's say there is a CV, it is given in a PDF format. A PDF is converted into a text format, and then that text is here. This is a text format, and these are the automatic process. A manual process starts from this location. So these things should be done manually. How manually? You need to first identify on yourself so that the machine can learn. So you need to identify that this task companies worked at. So at which company this person has worked. You need to first identify it manually. Algorithm is not gonna do everything automatically for you. So it is identified that, okay, this person is worked here, Oracle. Okay, and if we count the characters from here to here, to 1, 2, 3, 4 kind of that, so it will start from 1749. Okay, the characters, Oracle characters. Okay, it says that here January 2018 to present senior consultant, Oracle. All right, so this Oracle word starts from this character position to this character position. So it says that this is the companies at which this person is worked, and there are many mentions of this the Oracle. So you need to identify that, okay, what are the other position of that word, so that you can put that here. And then you see here, so companies worked at, there are 3 mention here. Then there is a mention of skills. So you can get those skills from here. Okay, so it has skills, and skills starts from this location to this location. So probably this starts from this location to this location. All right, and then similarly companies worked again, and if you see here the graduation year, so it says that the graduation year. Then you need to first manually find out where is that graduation year in which that person has graduated. So it says that this person education is BE in Computer Science, Aditya Institute of Technology, Tamil Nadu. It graduated in September 2008 to 2012. So you see the graduation year is this one, 2012, and this is the, so these things you need to do the manually. First of all, you need to understand this, okay? And then finally the college name. So the college name here, it says that this is Aditya Technology, okay? And then the location, designation, etc. You need to first manually find out from this text, and you need to prepare this kind of tuple. All right. If you do not have the data, so I'm going to post this data on the GitHub. You can get this data, and then you can follow along the video, and then you can write the code. I'm not going to post the code today. I have been found that the people have been just making a bundle of the codes and my videos, and they have been selling it at the high price in the market. So, but that was not my intention. My intention was to distribute all these codes and the videos in the free of cost to the everybody. But there are some nasty people who do not like these, and they take the codes and the videos and they bundle it, and then starts they selling it. Although, so I have taken some the action. So the talk to the few people, so the legal peoples like the police, etc., to find out those people who are really doing the infringement of the copyrights and violating it. Although, so let's go ahead and start it. So in this, what you get here, let me show you again this whole data. So there you see we have this one. Let's go ahead and see this PDF if we can see. I think this cannot be seen there, but anyway, let me get it there. Just a second. So the PDF is here, let's say. Okay. So what we need to do, we need to convert this PDF. Okay. This PDF into the text format, and then you need to get these text, and then you need to prepare all those data. So let's suppose that we have those data in this the training data.txt, and the same data is stored here in the pickle format. Pickle is very useful to preserve its data structure. So I also stored it into the pickle format. All right, now let's go ahead and back to this code. Okay, so the roughly I will be following this example here, SpaCy.io usage. Let me open this for you. Okay, so the roughly I will be following this. How do I get training data? Okay, so the training data, if you read these, it says that you need to prepare your training data manually. So you have here the text format. Let's say in this text format, let's say entity is here Uber and its label is organization. So it says that this entity starts from the 0th character position and it ends at the 4th character position. And similarly, you see here the label is a person here, this Android. Okay, so Android Play expands to the Canada. So this is not the person here if you say the Android Play. Okay, but if you talk about only the Androids, these Androids like in the technology, the Androids like a robot, in that case you can say this is a person. But actually this is the wrong here. If you say here, sorry, this is the Android Pay expands to the Canada, or you can say, I think now it is converted to, I think, the Google Pay. So this should be the organization here. And the Android Pay expands to the Canada. Again here, the Canada here, you see, the Canada is here, the GP, graphical geolocation. And that's okay, this is the country. And Spotify steps up Asia expansions. Now this is the organization. You see here the starts and the ends, how it is encoded. So this is encoding what is the start character and what is the end characters. All right. So this is how you do this. You can also do this with the rule-based matcher to only make something like this, but that is not always accurate. Let's say if you say that let's say if you say that this Google is a person, sorry, this Android is a person, then it will even Android operating system you will also take as a person, and Android PA will also take as a person in rule base. And then you finally prepare your training data. Do you remember here how we had prepared? We had exactly like this. Okay, we had first the text and then we had the labels. Okay, now there we had our custom label like the companies at work, skills, graduation year, the college names, degree, etc. So all those things. So this is how we did. And the code which I'll be following, roughly that code is here. So there are few changes which I had made in the code to make it easy for you to understand. But now you see here, this is the training data. Now this is exactly as we had seen previously. Now you see here, it has the first text data and then finally it has these entities from here. Okay, so this is the training data, and this training data then we will be feeding here in NLP SpaCy model. So we'll first read their blank SpaCy model, and then that blank SpaCy model, to that blank SpaCy model we will be retraining our algorithm. Okay, all right, perfect. So let's go ahead and start coding. Okay, so the first of all I'm going to load that training data. So here it says that we have train underscore data is equal to, let's go ahead first run this one. So we have imported here SpaCy, imported here pickle and the random. If you do not have SpaCy and the pickle, you need to install this. You can go ahead at my channel KGP Talkie and see I have taken many videos on this SpaCy, and then you can see there how to install and work with this SpaCy. So here we have a train data is equal to pickle dot load, and then finally I'm going to say that here the open and open train data dot pkl, and then finally here we have rb. Okay, so we have here a train data, then we have here a 0. Now you see this is the first training data. In this the first training data, if you see, it has the first text, and after that these entities which we had seen in the example. So these are the things on which we will be training our algorithm. Okay, perfect. So let's go ahead and roughly follow this code. Okay, so I'm gonna first prepare here a function. So this is going to be a little this is going to take a little time. So we have a def. Before def, we need to first load that model. NLP is equal to SpaCy dot blank. I'm going to load here EN model, that's the English model, and then I'm going to say that here df train underscore model, and there I'm going to pass there train underscore data. So this is the data which I'll be passing there, and once we have this train data, now what I'm going to do, I'm going to remove all the pipelines, and I'm just going to add there the named entity pipeline. Okay, since this is a blank model, so it do not have anything. So there I'm gonna add there NER, named entity recognition model there. So I'm gonna say that here if that's the NER. Okay, if NER named entity recognition not sorry if NER not in NLP dot pipe underscore names. If you do not know what are these pipes etc., I have taken NLP tutorials, around 15-16 tutorials, in which the perhaps 4th or the 5th lectures are there, in which I have talked about the NLP pipelines in the SpaCy. You can go ahead and watch that video. So there you will get all the ideas, what are these NER and pipelining etc. in the NLP. So we have if NER not in NLP dot pipe underscore names, then NER is equal to NLP dot create underscore pipe. So we have NER pipelining here, and then finally we are gonna add this NLP dot add underscore pipe, and then here we have NER, and I'm gonna add this NER at the last position of the pipelining. All right, perfect. So we have this here, the pipelining has been added. Now I'm gonna add the labels in this NLP pipeline. So how we can add that label? We have here for annotation. Let's say here annotation in a train data. Now you might be wondering that what is this? So this is nothing. I'm just skipping that, because you see this is the tuple, and this tuple has a 2 part. At the 0 index it has a text, so currently we do not need that text, and then it has the labels. So the label resides into the annotation that starts from here. Okay, so this is the annotation. So I'm gonna add this annotation there. So for underscore annotation in train data, for ENT in annotations dot get entities. Okay, dot get entities, otherwise you can just write here entities. Since this is a dictionary, you can just type it annotation, and then here we have entities. Okay, now it is going to, once we get these entities, now it will return this list, and then we are going here each object. Okay, so one object after the another. So we'll go first companies worked at, and then etc., all other things. Perfect. Then we are going to say that NER NER dot add, actually this should be the NER dot add label. Okay, NER dot add label. Then we have here ENT at the second position. At the second position, these are the labels. So this is these two first are end and the start character position, and then finally these are the labels which we are gonna add our custom labels in this. All right, perfect. So once we do this, now we are going to prepare our data for the training. So I'm just going to copy and paste this code, since this is going to take a lot of the time, and then I'll explain you it line by line. Let's say I have pasted this code from here. Okay. All right. So now you see we have got this NER in the pipeline, and then I'm gonna see that if there is other pipelines, and you see here this is exactly we are following here. Let me show you. Yes, you see here other pipelines, etc. And then we will be doing these things. So for the detailed documentation and the understanding of this lesson, definitely you need to read this later after watching this video. So we have here other pipes. They are pipe for pipe in NLP pipe names if pipe is not in here. I mean, it is saying that if there is more than one pipelines after this NER, then remove those pipelining. Okay. So the NLP dot disable other pipelines and train only the named entity recognitions. And here optimizers, we are getting here NLP dot begin training. And then this says that the iteration. So we are going to train it for the 10 iteration. And random dot shuffle is shuffling this the training data at every iteration. And then here we have losses and the index. And then finally you see here again we are going to read this train data. Okay, so we are again gonna read this train data, and earlier we had not read the text, but now we are also going to read this text, and from this text it is gonna match this annotation, and then finally here text and annotation. This is the drop. That's mean we are just making it a little harder to remember exactly how it is doing, since it will add the regularization in your model. And here SGT optimizer is being used there, and then finally the losses. So this is all. Let's go ahead and run this. Now we have our train data. As you remember, we have this train data. Now we are gonna pass this train data in this model, which is a train model. Okay, so let's go ahead and copy this train model, and then we are gonna pass their training data. So once we do this, you will see it starts the execution, but at the first step it is saying that it is not defined. Perhaps here. Okay. All right, let's go ahead and run this. So it starts the training. It might take around 20 to 30 minutes to complete its training. You see here, there is only the 200 resumes, the data, but it takes around the half an hour. So if you have a large data set, then definitely it is going to take a lot of the time. For some of my projects, it sometimes took around the 2 days or the 3 days to complete the training. So you have to the patient and to complete its training. All right, now you see the training has been completed. It took some time to complete the training. Save this model so that you can also use this NLP model for your future use, not only to these projects, and also it will avoid to retrain your model every time. So to save this model, your NLP model, what you need to do, you can just write there NLP dot to disk. There is dot to disk, and then I'm gonna say that here NLP underscore model. So this will write this to the disk. Now you see here we have here NLP underscore model. Okay, perfect. This model was already retrained, so I'm going to just remove this. This says that okay, this cannot be removed from here, but let me delete it from the original position. Okay, now you see model is removed there. Now let's go ahead and load our this NLP model. Okay, although this model is already loaded into the NLP, but I'm gonna also show you that how you can train how you can load already trained model. To load this already trained model, let's go ahead and load it into a variable. There we have NLP model is equal to SpaCy dot load. Do you remember we had loaded first the blank model, but now I'm gonna load here already trained model, which is NLP model. Okay, so now this is loaded into the NLP model. Okay, now you see here we already have this NLP model instance here in the NLP, but here we are also having it into the NLP underscore model. So it will help us to load this model even though if you are working at some other time and you do not also need to train it every time. Okay, so let's go ahead and see our training data. We already have our training data, train 0, let's say this one, and the train 1 is something like this one. So let's go ahead, just take the train 0. Okay, so this was our the training data, train 0 data. Earlier it was something else, but since we did here train random.shuffle, so this data has been changed. Okay, it has been shuffled, the data is same, but the position of each of these data has been changed. Earlier, if you remember, at the train 0 something else was coming, but now since the shuffle has occurred, so it has changed and it is giving another name. All right, so it is not preferable to test our model on the training data, but to just understand how it is working and to get this some idea, let's go ahead and pass this data to this NLP model so that we can understand how it is identifying these things. So we are going to just pass this text, and then our model should return something, the college name, degree, etc. from this text. Okay, since we have already trained our model. All right, so we are gonna say here doc is equal to, we have here NLP underscore model. This is the recent model which we loaded here, and there I'm going to pass the train data. Okay, so this is the train data underscore 0, and then we need to load only this text value which we can get from the 0th position. So this is the 0th index. So with this we have got it, and now I'm gonna say here for ENT. So here we have a for ENT in doc.ent, that's the entity's name, and then I'm gonna print it with the padding. So I'll tell you how it is working. So this formatting tells that, let's go ahead first print here ENT label, that's mean the predicted label which it is predicted, and then finally the text, which label, which text is corresponding to which label. Okay, so we run it. Once we run it, now you see here it is saying that okay, Samir Kajur is name, location is Orissa, this is email, designation, degree, college name, and the skills. All right, so this is how it is working. Okay, so this is we have tested it from the already the data which is available on which we had trained it. Now let's go ahead and do a classification from unseen data. So here I have a few here doc files in the PDF on which I'm gonna test it. So let me show you this doc file. So currently I'm having this doc file ls Clark. So this file is not included into training data. So this should work on this file. Our algorithm should work on this file. So the first of all, what we need to do, we need to convert this PDF into the text format. We need to extract the text from this PDF, and once we get the text from this PDF, then we need to pass it for the classification. So to converting that text into a PDF, we need to install here PyMu PDF. Do remember, you need to install this or some other. I had also tried the PyPDF too, but it does not work. Okay, it does not work properly. It had extracted PyPDF2 had extracted the information from the PDF, but not all the information, and it was also returning some garbage characters as well, and it was skipping the most of the information from the extraction. So I do not recommend this PyPDF2, and I have found that the PyMu PDF has worked better than the PyPDF in case of this project. But if you have some other project and PyPDF2 is working, then it's a great. All right. So you need to install this. I have already installed this, so I'm gonna just comment it. Otherwise, you need to install this PyMu PDF. So having said that, let's assume that you have installed this PyMu PDF. Then what you need to do, you need to import sys from here, and you also need to import here fitg. And once you get here the fitg, then we are gonna give here the file name. So file name which we have currently is ls clark cv.pdf. So this is the file on which we are gonna work. This one, okay, ls clark cv pdf. And then I'm gonna say that here doc is equal to fitg, okay, dot open, and then f name, so it will open this file. Then I'm gonna say that, okay, get a empty text. Then for page in this doc, it will get all the page. The text is equal to text plus str. I'm doing str because sometimes only integer character can be it can only return some integer characters or non-str characters. So that non-str characters will not be appended with this the string. So it might throw an error. So here str page dot get text. Okay. So we have here this one. Now once you have this, let's go ahead and print this text. So once we print this text, now you see there are many new lines, and if you use here this print, you will see now this PDF, all this information from this PDF has been extracted, and this information is now printed into the text format. Okay, great. So I have found that this PyMu PDF has worked better than the PyPDF. All right. So this is all here. It has extracted, but now you see here there is a lot of the special characters and the new line. So what we are going to do, we are going to remove those new lines. So to remove those new lines, I'm gonna use here join and then text dot split with the new line. So how it is going to work? It will split from a new line, and then new line will be discarded, and without a new line, then this text will be joined with a space. That means new line will be replaced with a space, and then finally I'm gonna print this tx. Now if you see here that new line has been removed and all other things are exactly the same as it is. Okay, so now I'm gonna copy this one. Once I copy it, and then I'm gonna paste it here, and in this, as you see, we have our text in the form of tx. All right, so the tx is gonna pass into NLP model, and then finally I'm gonna run it. Once I run it, wow, this is super, this is great. Now you see you have got here a name, location, designation. It says that designation is stream analytics, and also designation is a software engineer. You see here there is a little error, but all those things are kind of the same. You do remember, if you are a data scientist and if you have already data and you are just developing algorithm, believe me, then you are not a true data scientist. The the true data scientist's job is not only to develop algorithm, but also to understand the data and prepare this data. Okay, but sometimes you might have already the data, but to prepare that data according to your need and get the information, the desired information from that data is a real task of data scientist. So it says that designation software engineer, companies worked at the Microsoft. You see here there is a little error. It says that the degree is Indian Institute of the Technology, Mumbai, although this is the institute from where that this person has passed out. Okay, and skill, it seems that it has given a skill quite good, and additional information it has also predicted quite good. So with this, having said all these things, now I'm sure it will help you to understand the CV parsing and the resume parsing in a better way. And if you increase your data set and if you include a various kind of CV and the resume in your data set, then definitely all kind of the CVs and the resume you can parse without any problem. Okay, do remember, this is small data set is not going to always help you to parse CV and the resume. This is a big project. You need a lot of the time. You need to give a lot of the time to prepare the data, and after that you will be getting a good result. But for the beginners, for getting started, how you can do the CV parsing and resume parsing, this is definitely going to give you a great head start. Thank you so much for watching. If you are visiting first time this channel, and if you have not subscribed my channel, please do subscribe, like and share this video to show your support. Thank you so much. Bye bye and take care.